Okay, previous class, so you people understood how to insert at the front to a singly linked list and how to delete from how to insert at the rear in a singly linked list, and then how to create a node, all these things. Okay, and this was the example which was taken in the last class to demonstrate how insertion is done at the front and how insertion is done at the rear end. So now we'll understand how to delete from the front first. Okay, how to delete from the front, how to delete from the rear, and then how to display the current content of the singly linked list. Okay, we'll understand now delete front, which is the case 4. Okay, if you choose option or the choice as 4, you'll come to delete front. And I've already told you in the last class what is FI is. FI is nothing but what?
First pointer.
First pointer. So FI is pointing to the first node. Okay, so if you just look here, this diagram. Okay, so first is pointing and FI is also pointing to this. FI and first both are pointing to the first node. This is the first node, this is the second node, and this is the last node, which is at the rear end. I'm going back here. Now what you're passing is the first, okay, and the function that is called as delete front. So now let me go to the delete front. So this is read data, which you have understood already in the previous class, and this is create node, which you have already understood. So insert front, which is already discussed. Rear, insert rear, this is also already discussed. Now delete front. Okay, so just have a look here. What is that you got to do now? You got to delete the node which is pointed by FI. This has to be deleted, and first should be made to point to this node. So that is what we got to do now, only this much. So you make first to point to this node, okay, and delete this. Okay, now to delete this, before I make the first to point to this node, I have to take one more pointer and I have to make that pointer to point to this node, and then advance the first pointer to point to this. And now there will be one more pointer pointing to this node. Using that pointer, go for freeing this node or deleting this node. Okay, people understood?
Yes, sir.
Okay, now we'll go here, delete front. See, node TE I have taken. Okay, so because I told I need to take one more pointer. Okay, one more. See, FI I have copied. So first is pointing to the first node now, and I've taken one more node TE, or one more pointer to my node, that is TE. And if first is equal to null, I'm checking if first is null. Okay, can't delete from an empty list. So if first is null, I just say it is an empty list and cannot be deleted from the empty list. So if first is not null, I go to the else part. Just observe here. Now what I'm doing? So I'm doing T is equal to first. What does it mean? So TE also points to this. Right now FI is pointing, first is pointing, and TE is also pointing to this particular node, first node. Next. And then what is that you got to do now? So this node is you're going to delete this now. You're about to delete this node now. Now you got to make first to point to this. Okay, how to do that? First is equal to first arrow link. Okay, so first is right now pointing to this node because its address is 0500. Now I want to make the value of the first as 1000. Okay, how to make it? So first is equal to first arrow link. In first arrow link there is 1000 stored. Now what happens? First will get the value 1000, and it is no longer pointing to this, and first is pointing to this. One second. So first is pointing to this, and its value is equal to how much? 1000. Okay, next what you have to do? So free TE. So I got to know delete this node. So and who is pointing to this right now? See, first I have made to point to this node, and to this node I have intentionally made TE to point. Now using this pointer TE, I go for freeing this memory. OP people are following?
Yes, sir.
Okay. Now what we do now? We just say free TE. This is again the dynamic memory allocation function. Whenever you call free by passing the pointer to which by passing the pointer, so it's going to free that memory location. Now this memory is freed. I'll delete this. Oh, sorry. So this is removed now. Okay. People understood how delete from front happens? So before deleting, what you have to do, you have to take a one more pointer, make that pointer point to the first node where first is pointing, and after making the temporary pointer which you have taken to point to the first node, go for incrementing the first pointer and make it to point to the second node. Okay. How to do that? First is equal to first arrow link. Now first is pointing to the second node. Now go for calling free. Okay, free, and pass that temporary pointer, free TE. Okay, free TE. Now it deletes, and then return first. Okay, now return first, because first is earlier it was pointing to the address 0500, now it is pointing to the address 1000. OP people understood how to do the delete from the front. It's easy. Understood now?
Yes, sir.
Okay. Now similarly, how to do the delete from rear? Okay. Let me just do Control Z, because I'll take this node as it is. Okay. I'll just come back to the original state. That's all. Okay. So assume this is my new list now. Okay. Now we'll go to delete rear. Now case 5 is delete rear. Okay. Delete rear. I'm passing the first pointer again. So we'll go to the function delete rear now. This is insert front, delete front. Now delete rear. First I'm passing. Okay. Now node, I have two pointers here, current and previous. Okay, PRED, anything you can take. Again I am checking if first is equal to null. First is equal to null, what does it mean? It's an empty list, you cannot delete, and return first. Otherwise, if first is not equal to null, okay, now you got to check first arrow link is equal to null. You got to check whether the list contains only one node or not. So if the list contains only one node, so that itself is the first node and last node. OP people are following what I am telling? See, first here I check whether the list is empty. If the list is empty, I display this message, can't delete from an empty list. Next what I am checking is, I am checking whether the list is with only one node. Okay. So if the list is with only one node, what does it mean? So that itself is the first node and that itself is the last node. What is that you have to do? See, so if first arrow link is equal to null, so you are checking, see this is the first node right now, this is the first node. If this link field is null, what does it mean? So list right now contains only one node. Okay, what you have to do now? If there is only one node, return first is equal to null. Return first is equal to null. That's all. Okay. If more than one node, what do you have to do? So right now in our case we have more than one node. We have three nodes. So what we are doing, just observe here. So I am making cur is equal to first. What happens? Tell me. Tell me what happens. Cur also points to the first node. OP people are following? Hello? Please speak.
Yes, sir.
Yeah. See, current is equal to first you are told. So current also points to the first node. Next, what you have to do? So I am running a while loop because I need to reach the last node, correct? No, current arrow link not equal to null. Okay, I say PRED is equal to current. Previous node is equal to current. Okay, so I am checking here. Current is pointing to this, while current arrow link not equal to null. Yes, not equal to null. What I do now? I take one more pointer. PRED also pointing to this. Okay, observe here. I don't know whether I'm scrolling up and down, whether it is distracting you people or not. So, but I don't have any other option. I have to go with this. So, or is that okay?
Yes, sir.
Yeah. See, previous is equal to current, and current what I'll do? I'll increment it. Okay, current is equal to current arrow link. So first I make previous PRED also point to this, and next current is incremented and made to point to the next node here. Current is pointing to this, and again, since it's inside the while loop, what we are doing? Check here. While cur arrow link not equal to null, so current is pointing to the second node now. So cur arrow link, it is not null. What you have to do again? So PRED is equal to current. What will happen? So this PRED points to this now. Points to this, and current is equal to current arrow link. Current goes and points to the next node here. I'll write here. Current is pointing to the last node right now. Now again come back to the while loop. While loop. While current arrow link not equal to null, is the condition true now? Current is pointing to the last node, and the link field of the last node is what? Null now. Null not equal to null. Condition is what? Hello?
False.
Condition is false. Okay? Condition is false. That means, so no further incrementing. We stop at this point. That means we come out of the while loop. Okay? So we are out of the while loop, and we are saying free cur. Okay? Free the memory location pointed by current. Now where current is pointing? So current is pointing to the last node. OP people understood?
Yes, sir.
Free this node. Okay? I'll delete it. So this is deleted. Okay? And next, so which one should be made as the last node now? The node to which PRED is pointing. Okay? So PRED is pointing. So now PRED is pointing to this node, and now this should be made as what? Null. Now, so what you do? PRED arrow link is equal to null. So this you are making it as null. Okay, and then return first. Okay, PRED, sorry, it's not pointing to this now. Return first. First is still pointing to this. Hope you people understood?
Yes, sir.
Let me summarize now. So when you want to perform the delete operation from the rear end on a singly linked list, what you have to do is you have to take two pointers. So one I am calling it as current, another one I am calling it as PRED. Now what I'll do, I'll make current to point to the first node. After making the current to the current CUR to point to the first node, so before making CUR to point to the first node, what I'll do, I'll check whether the list is empty. If first is equal to null, I say can't perform the delete operation, list is empty. Next I go for checking if the list contains only one node. Okay, if list has only one node, what does it mean? That itself is the first node, and that itself is the last node. Now what does it delete is nothing but, so you have to return, assign first is equal to null and return first. Okay, so make first as null. That's it. If there are more than one nodes, what you have to do, make current to point to the first node. Okay, and run a while loop. while current arrow link not equal to null, make PRED as current. Make PRED also point to the current node and go for incrementing the current. Current is equal to current arrow link. Okay. Do this until current arrow link becomes null. The moment the current arrow link becomes null, that means the current is pointing to the last node, CUR is pointing to the last node, and PRED is pointing to the last but one node. Now free CUR and using PRED set the link field of the last node to null. PRED arrow link is equal to null. Hope you are able to understand the summarization what I did.
Yes, sir.
Okay.
Yes, sir.
Now, so we are done with delete front and delete rear. Okay. Next is display. How do we display the content of the list? Now we'll go to that is case 6. Okay. When you enter the choice value as 6, so you're making a call to display and you're passing the first pointer. Okay. So we'll go to display now. Yeah, this is the display function. Okay, so note first and again. So I've taken a count variable and it is initialized to 0 and while first. Okay, so if first is not null, correct? No? So this first is some address it is holding, correct? No? It's a positive number. So while true, so we come here and then we just, because I'm just trying to print it in the form of the table. Okay. Yeah, sorry, not the table. First I'm printing the USN field of the first node, name field of the first node, branch, semester and phone number, and each one is separated by a tab. And after that what is that I have to do? So I should go for displaying the fields of the second node. So I got to increment the first. So first is equal to first arrow link. Okay, and then count plus plus. So because I want to count the number of nodes also, I am increasing the count plus plus. And next, in the next loop what happens? It will print the content of what? The second node and the third node. So till all the nodes are covered. So OP people understood? Is there any doubts in the display function? It's easy. Hello?
Yes, sir.
See, if you don't want to make the first pointer point to the next nodes, what you can do is instead of first you can take a different node also. Okay, so pass first. So and here what you can do is one more node, say disp PTR, display pointer. Okay, what you can do is disp underscore PTR is equal to first. So now the display pointer also points to the first node. Now instead of while first, you can take it as disp underscore PTR. Okay, and then here instead of this first everywhere, you have to change it to display underscore PTR arrow USN, display underscore PTR arrow name, and then display underscore PTR is equal to display underscore PTR arrow link. Okay, count plus plus. OP people understood now? Because I don't want to disturb the first pointer, I want the first pointer always point to the first node. Is it clear?
Yes, sir.
Even when you are
Yes, sir.
displaying, if you don't want to disturb the first pointer and if you want to make it always point to the first node, so then take one more pointer, okay, and make that pointer to point to the first node itself, and for display purpose use that pointer. Okay, and everywhere wherever there is first, you got to change it to display disp underscore PTR. So and go for printing, and simultaneously you're also counting the number of nodes, and after displaying the content of all the nodes, you're printing how many nodes are there also. So this is about I think we have finished all the functions of the singly linked list. Okay, and display was the last thing, and case 7 is for terminating the program. initially done, we have initialized it to 0, and while not of done we are checking. So when you don't want to execute this further, so then you enter the case or the choice value as 7, and you are making done is equal to 1. So while not of 1 is 0, while 0 condition is false, and it will come out of the while loop and the program gets terminated. So till now you understood the singly linked list and its various function. Now it is time to execute and perform the debugging operation. Okay, so now I'll open the Turbo C. Okay, I'll open the 7th program. Okay, so it is the same thing which I've already explained to you people. It's the same program. Okay, all the functions are explained. Read data, create node, so this was explained in the previous class. Insert front was also explained in the previous class. Insert rear, this was also explained in the previous class. Delete front was explained in the today. So delete rear explained today. Display explained today. Okay, so now, and again I don't want, let me change here, because I don't want the first pointer to be affected. Okay, yeah, no problem, I think, because we are not returning. Okay, see here we were returning first. Now if I modify the first pointer and if I return, so observe what I am saying. See, I am incrementing first pointer and finally I am returning. So if I return, what happens? The first pointer gets updated. Since I am not returning, I can retain the first itself, no issues. Or otherwise, so you can always declare a new pointer. Okay, so now as of now nothing will happen. So it's not going to disturb the first pointer. What we do, because we are accessing only in this function and we are not returning it. Okay, if I return the first pointer, so then it gets affected. Since I'm not returning, it will not get affected. Okay, so now let me compile this. So if it confuses, sir, why we are modifying the first pointer, first should always point to the first node. So we just don't want to modify the first pointer. So then you can take one more, declare one more node, and say take it as disp underscore ptr, make disp underscore ptr is equal to first, while disp underscore ptr, I'll change it, disp underscore ptr here also ptr disp underscore ptr disp underscore ptr. Now here, instead of first is equal to first arrow length, we'll just do it as disp underscore ptr is equal to ptr. Okay, I'll save my program. I'll compile now. There are two errors it is showing. So declaration not load here. Okay, so let me remove this and put here, because it is an integer variable, comma here. Okay, n is for the number of students. I'll save it. Okay, one more error. Function should return a value. So that is warning, it's okay. So declaration not allowed here. Okay. Okay, that means it should be first, and count is equal to 0. I'll do it here. Okay, sorry, save the program. See, whenever you're writing the definition of the function, the immediate statement should be what the declarations. Okay, now it is done. See, the program, all of you can see the execution window.
Yes, sir.
Okay, so now we'll go for creating first. Choice 1, enter the number of students, say 3 students I need to insert, or 2, okay, 3. Enter the student data, student 1 data. So I'll take the USN as 001, name ABC, branch CSC, semester 3rd, okay, and phone number. Enough. Okay, now student 2 data, USN 002, name XYZ, branch I'll take ECE, and then semester 3, and some phone number. So student 3 data, I'll take 003, and then name of the students PQR, branch, let me take CSE again, semester 5, phone number, some phone number. So 3 student data I've already inserted. Okay, so now we'll display 6. See, all the 3 students data. Okay, so I've entered their USN as 001, but 001 is nothing but what? Integer. 001 is nothing but what? 1. It is taking it as 1 only. 1, 2, 3, and their names, and then their branch and semester and their phone numbers. Okay, now can you tell me what is the front node here? Or the first node? Which one is the first node? Students?
1.
No. See, in the create option, okay, let me go back to the program, I'll show you. In create, which one we called? Have we called insert front or insert rear? In create. So that tells you which one is the first node. Okay, let me go. Oh, sorry. Where is the program? Output window. I have to press to go back to the program. No, I cannot go back. I'll show you here. Here, see, case 1 I did now. Enter the number of students, and then I called create. Let me go to the create. So create, enter the student data, you're reading the student data, and after that, what is the function you're calling?
Insert front.
Insert front, correct, right? Insert front you're calling, and insert front will insert at the beginning. Now which one is the first node? And now you can tell. So when I'm not calling insert rare when I'm creating the singly linked list, what I'm calling it, which node which function I'm calling? Insert front. Since I'm calling insert front, yeah, tell me which one is the front node now?
3, sir.
3 is the front node. And which one is the last node? 1 is the last
1.
node. Okay.
1.
Okay. Now how to know that? See, I will go for delete. Okay. Now delete from the front. Okay. 4 I have taken. Now for me, the first node is what? The node with the USN 3. Now that should be deleted now. Okay. So I'm doing delete from front. I'll press enter. Okay. It is deleted. Now I'll go for display again. 6. Now 3 should not be there. Sabja now? Is that clear?
Yes, sir.
So when you are creating the node, create as performing what type of insert? Insert rear or insert front? It's performing insert front. Okay. That means the node which you insert most recently will be the one to be in the first of the list. Okay. Next. So let me call the function insert front. So now I have 2 nodes. One node with USN 1 and another node with the USN 2. Can you just tell me which node is at the front now? And which node is at the rear end?
2 is at front.
2 is at front and 1 is at the rear end. Correct, no? Now I'll go for option 2, choice 2. I want to insert at the front. Now it is asking me enter the USN. Okay, let me take 3 again because I deleted it. Let me put it back. 3. Name PQR and then CSE branch, 5th semester, some phone number. Done now. It is inserted. Now if I go for display, so you can see 3 is added at the front. Okay. So the front node is with the USN 3 and the rear node is with the USN 1. Okay. Now we'll go for inserting at the rear end 3. I am taking the choice 3. So enter the USN. So say I want to I am trying to insert at the rear end. So I'll take the USN 4. So name as LMN and branch is say mechanical and semester is say 7th semester and some phone number. Now this is inserted at the rear end. Now where it should come? Now if I go for display, where can you see this? The node which you are inserted right below 1. Correct? 6. You can see now 3, 2, 1, 4. Number of nodes is 4. Correct, no? Now the starting node is 3 and the node at the rear end is 4. Okay. So now let me go for deleting from the rear end now. So 5. Choice 5 I am choosing. So deleted. Which one is deleted now? The one which we inserted right now. Okay. That is 4, LMN, mechanical, 7th semester and phone number 5263773. This gets deleted. Now I'll go for displaying. See, that is deleted. Okay. And the question also mentioned demonstrate, correct, no? The stack operation on this, correct? So if you go for what inserting and deleting from the same end, so it's nothing but what If you go for performing insertion and deletion from the same end, what does it mean? What data structure it is? Hello?
Stack.
Stack it is. And the question also says that. So I'll just go to the question now. He also says demonstrate. Where it is? Yeah. Perform insertion or deletion at front of the SSL and demonstration of stack you have to show. Okay. Now we'll go for inserting and deleting from the front end, and which is something like a stack right now. Okay. Now if I ask you a question, what is the top of the stack now? So if I am viewing the singly linked list in from the stack perspective, what is there at the top of the stack?
3.
3. The one which is more recently inserted is what? The top of the stack, correct, right? Which one is the node that is most recently inserted? 3, because that is there at the front. Yes or no?
Yes, sir.
Okay. Now I want to push one more. Now I want to push. Now I'm assuming the entire singly linked list, as a stack. Now I want to push one more element. Now which one I have to choose now? Should I choose insert front or insert rear?
Insert front.
Insert front. I'll go with the 2. Now USN say 4. Name some AAA and then branch. So let me take ISC branch and then say Mr. 3. Okay. Phone number. So now I'll display. See, 4 is inserted, above 3. So that the first node is what now? 4. Let me go for inserting one more at the front, 2. So USN, let me take it as 5, and name is BBB, and then branch is, so we'll take triple E branch, and semester is 5, and some phone number. Okay, now I'll go for display. See now? Now I go for deleting. So stack I need to demonstrate now. I need to pop. Okay. Now which function should I call? Delete front or delete front? 4. So done. Okay. Now I display 6. See, 5 is deleted. Okay. Now again I'll call 4. Now I display. See, 4 is deleted. Okay, people understood?
Yes, sir.
If I go for inserting at the rear end and deleting from the front end, now which data structure I am demonstrating? So if I go for inserting at the rear end and deleting from the front end, which data structure I am demonstrating?
Q.
Q. Okay. Now we'll do that also. Okay. Now and I'll. So this is now. Tell me which is the front end and which is the rear end now. Looking into the current status of the singly linked list, tell me which is the front end and which is the rear end. Students?
Front is 3.
Front is 3 and rear is 1. Correct, right? Now, I'll go for inserting at the rear end. 3. Option is 3. Okay. So I want to insert one more. Say 4 and name DDD, branches IEM, and then semester is, say, first semester, and phone number this. 6 I display. Now inserted at the rear end. Okay, I've inserted at the rear end now. Let me insert one more at the rear end. USN. Okay, 5. Name is RRR. So branch is ETE, and then semester is 5, and some phone number. I'll display. So 2 nodes I've inserted at the rear end now. Now I'll go for deleting from the front end. Deleting from the front end will demonstrate you the working of the queues. Okay, so you can implement stacks using singly linked list, and you can also implement queues using what? The singly linked list. Hope you people understood.
Yes, sir.
Is it possible to implement the circular queue using the singly linked list? Yes, it is possible. So the last node, the link field, correct? No, what we have done right now, we have stored null, correct, right? Instead of storing null in the link field of the last node, you just store the address of the first node. It becomes what? A circular singly linked list. And using circular singly linked list, you can easily go for implementing the data structure circular queues also. Is that clear?
Yes, sir.
Okay, now I'll go for deleting from the front end. So because I want to demonstrate the queues also, I'm deleting from the front end. So delete from the front end. So option is 4, choice is 4. So now I'll display. So which one? 3 should be deleted. So 3 is deleted. Correct? So in queues, so the node which is entered into the queue first will be the one to be removed first. Okay, so next, so again 4, so node with the USN2 will be deleted. Okay, now again I go with 4, node with, and then display node with USN1 is deleted. Now again I go with 4, node with, I'll display node with USN4 gets deleted, and again I'll go with 4, node with USN5 gets deleted. Now I'll display. So it's okay. See, so 6 I've given. So number of count of nodes is equal to 0. That means it is an empty node. Correct now? Yes or no?
Yes, sir.
Okay. I hope you people understood with the, now I'll go with 7. So exiting. Okay. So please, if you have anything to ask me, please ask. And here, as I told you, if you don't like to use first pointer, because first our mind is, we have set our mind that first is always pointing to the first node. So leave it as it is. Take a different pointer and make that pointer to point to the first node and use that for displaying. Okay. So if you have anything to ask, please do ask me. So nothing to ask?
No, sir.
Okay. See, the program looks bigger, but if you understand it, there's nothing in it. It's easy. So that's my sincere advice to you people is to understand and try to write the program without seeing. Okay, so 1 or 2 times you can just write by looking into the program. So practice it 1 or 2 times, Okay, and after you practice it for 1 or 2 times, close your book, close your laptop, everything you close it, take a paper, a pen, and start writing by yourself. So just take the question, that's all. Keep your syllabus copy with you, you'll be having the question in that. So just look into the question and start writing by yourself. Correct? When you start writing by itself, you'll understand now what are the variables required. Correct? How many variables I need to declare, all these things. Write it once, okay, and just compare that with the program which I have given. So just compare it. So you'll come to know the places where you have made the mistake. So once you realize those mistakes, so that mistake again you'll not commit in the future. Correct? Because you're realizing that mistake one after you write it by yourself. Correct? So that mistake you'll not commit again in future. Okay? So again write again one more time. For the second time you write without saying. So take that program. So don't go for comparing. Okay? First time when you write without saying, so compare that with the program, original program which I have given. If there are any mistakes, please do correct it, and you'll also understand what mistake you have done, and go for writing it for one more time without saying. And that paper, you just take that paper, the second time what you have written, sit in front of your laptop or the desktop, so see the same program and try to execute it. So when you write it, so you may get some errors, okay, so syntax errors. Try to clear them. Try to clear the syntax. That is the first thing. So logical error, look into that part later. First what you have to do is, you must be in a position to clear all the syntactic errors what you get. Syntax error. Once you do that, if there are minor logical mistakes in the program, so that you can always correct it by performing the debug operation. You can use F7, you can debug the program. So once you start debugging, and if you know the proper logic, you can easily rectify the point or the place so where you have made the logical mistake. Okay, and the same thing. So this attitude or this habit you have to cultivate, because this is required throughout your life. Okay, so not necessarily during your college life. So not and this habit is not restricted only to the labs or the lab programs what you do. So this attitude or the habit is required. So even when you join the companies, and when you are working for some company. Okay, so I think since I've explained all the functions in detail, do you require me to debug this program by using F7, or you people will try to debug it by yourself?
We will try, sir.
Yeah, so do that. So you have to do that. See, debugging is very essential. Okay, so only when you debug, and when you're debugging, you should try to sync the logic what you know with the debugging process. See, if you don't know the logic and if you're simply trying to debug, it will not help you. Correct? So when you're debugging the program, the logic and the process how you debug the program should be synced. So only when those two sync, you'll understand. Otherwise, nothing will happen. Okay. We'll stop here for today. So I'm done with the program on singly linked list also, and from tomorrow we'll start discussing the doubly linked list. Okay. So I'll go with the PPT presentation, and on doubly linked list also there is a lab program. Okay, so first we'll understand the theory behind the doubly linked list, and then we'll take up the doubly linked list. So maybe this Thursday, we will have the program on the doubly linked list. If not possible on Thursday, So if I don't complete the theory of doubly linked list before Thursday, so no problem, because 7 programs I've already given you. So we will have the next program for the next week. Okay. So now I'll wind up the session after taking the attendance. Just don't leave until I take the attendance in the portal. $350, $43, $135, $156 absent. So 10 is there. 10, 16, 39, 116. Okay. $116, $134, Samarth Gowda, $135, $135 is there, $136, Sankalp Singh, absent, and then $137. So I think these two people are irregular, Samarth Gowda, this one, Sankalp Singh and Shankar Singh, they are not attending from many days. 138, 140 is there, 141, 141, 141. Oh, I'm getting few WhatsApp messages also. I'll look into them later. 142, 143, 144, 145, 146, 147, 148. Okay. $149, $150, $151, $152, $153, $154, $155, $156, $156 is not there. Suhas M. $157, $158. Okay. $159, $160, $162, $163 is not there. $164, $165, $166, $67, $168, $169. $170 is also not there. $171, $172, $172, $174, $175, $176, $177, $78, $179, $180. $181, $182, $183, $184, $185, $186, $186, $188 is not there. $189, 190 Yamuna is also not there. 191, 192. Okay, 193 is also not there.
Excuse me, sir.
Yeah.
193 just got disconnected, sir. She was present.
Okay, 193, no? Okay. So that's all. Any other issues with respect to the attendance? Okay, thank you.
Excuse me, sir.
Yes, tell me.
Sir, I had a doubt about the lab internal, sir.
Yeah, what doubt?
Sir, can you just tell how it will be connected, or like how will we write the programs in Turbo C on our computer, or will be connecting to lab computer, sir?
No, can you connect to the lab computer? So first we will ask you to write as you did in the theory test. Okay, you have to turn on your camera. You have to write. We will tell you randomly the program. Okay, so that program you have to write. So you have to turn on the camera. You have to write in a sheet of paper. Immediately you finish writing the program. Okay, you have to share it.
Okay, sir.
Through Teams only. Okay, Teams we will tell you how to share it. Okay, so we will look into the program, and based on the program what you have written, we will be asking you the Viva question. Now after you answer Viva question, you will be allowed to execute. You have to execute from your system only, and then you have to share the screen.
Sir, if by chance we have made any mistakes while writing, can we correct it later?
No, we will ask you there only. Your Viva question will be based on that only, the mistakes what you do.
Okay, sir.
Okay. We will try to extract the answer from you people itself.
Okay, sir.
Yeah?
Okay.
See, ultimately, even you also have the responsibility, correct? No, everything we cannot monitor. But ultimately, it depends on you. So you got to prepare, and then you got to prove that, correct? No? So you're doing without any copying. So
yes, sir.
More than us, the responsibility is on you people now. Okay. So that's what you got to behave, honestly, and you got to behave ethically. So if you follow those two, correct? No, even I don't have to monitor you people. So ultimately, so you have to ask your question what I have learned. So if you're copying, definitely it shows that you have not learned anything, correct, right? So you in the sense, not you. So I'm generally addressing. That's all. Okay. Yeah, prepare well. First 5 programs, prepare well. Okay.
Yes,
So
sir. Thank you, sir.
Yeah, we will end the meeting.